Hello and welcome to another lesson from Level Up Mathematics. In today's lesson, we will be exploring how to solve a rational equation. Before we do, let's look at a couple of steps. So in step one, you want to determine the domain restrictions by setting each denominator equal to 0 and solving. These will be the values that are not allowed in the solution and are called extraneous solutions. So, for example, if I had a rational equation like 3 over x minus 4 equals 2 over x plus 7, x could not equal 4 because if x equals 4, then in the first fraction, in the denominator, 4 minus 4 would be 0, and that would be undefined. And x could also not equal negative 7. So these are called domain restrictions. In step 2, you're going to multiply both sides of the equation by the least common denominator, or the LCD, so that the fractional nature of the equations is limited, leaving us a simpler equation to solve. In step 3, you will solve the new equation, and in step 4, you'll check for extraneous solutions. Now, I think these steps will make a little bit more sense after you see a couple of examples. So in example 1, I want to determine the domain restrictions. So the only two fractions where we have a variable in the denominator are here and here. And so the only domain restriction here, we cannot have x to equal 0, because if it equals 0, 4 times 0 would result in 0 as a denominator. So that's our domain restriction. The next thing we're going to do is find our LCD. Now, to find the LCD, you want to look at all of the denominators. So I have a 2, a 4x, and a 4x. So my LCD is going to be 4x. Now, in the next step, you're going to multiply every term in the equation by the LCD. So in our first fraction, we would have 4x times 1/2 minus 4x times 9 over 4x is equal to 4x times 3 over 4x. So that's step 1, multiply each term by the LCD. Now, after you do that, you're going to cancel whatever can cancel. So 2 would go into 4 2 times. Here, 4x would go into 4x 1 time. Over here, 4x would go into 4x 1 time. Whoops. Now, write down whatever's left over, and that's going to be your remaining equation. So in our first term, we have what's left over is 2x times 1, which is 2x, minus, looks like 9 is all that's left over there. And on the other side, it looks like we have 1 times 3 left over, which would be 3. Now, if you look at your steps above, step 3 says solve the new equation. Well, this is just simply a 2-step linear equation, something you've been solving since 6th or 7th grade. So I'm just going to add 9 to both sides to get 2x equals 12, and then divide by 2 to get x equals 6. Now, you want to check your domain restrictions. The only thing x could not equal was 0. Since x equals 6 in this problem, this is not an extraneous solution, and we can box it in. So this is the value of x that would make this equation true. Okay. Look at example 2. Solve the equation x over x minus 2 plus 2 is equal to 8 over x squared minus 4. Now, before we start, I want you to look at this denominator here. To make this problem a little easier to figure out the LCD, we need to factor it. So this is a difference of 2 squares So it would factor to x plus 2, x minus 2. Okay. Now let's set our domain restrictions. What can x not equal? Well, if you look at your first denominator, x cannot equal positive 2. X cannot equal positive 2, because if it were to equal positive 2, 2 minus 2 would give you 0. Okay. Now, if you look at your last denominator, the x squared minus 4, we find that x cannot equal negative 2 either, because negative 2 plus 2 would also give us 0. So those are our two domain restrictions. Okay. Now, our LCD will simply be x plus 2, x minus 2. All right. Now, we're going to multiply everything in this equation by our LCD. So I'll start out by saying x plus 2, x minus 2 times x over x minus 2 plus x plus 2, x minus 2 times 2 is equal to x plus 2, x minus 2 times 8 over x plus 2, x minus 2. Now, I know it takes a lot of time and a lot of room on your paper to write all this out, but trust me, it is worth it. You will make fewer mistakes if you write all this out. It makes the next step so much easier. All right, so once I've got every term multiplied by the LCD, now I go through and cancel what I can. So x minus 2 cancels with x minus 2. The second term, nothing will cancel. On the right side of the equal sign, all of this cancels with all of that. So that's the only thing that cancels. So once you get everything canceled, then you write down what's left over. So in our first term, what's left over is x parenthesis x plus 2. Then we have 2 parenthesis x plus 2, x minus 2 equals, and the only thing left on the right side is an 8. All right. Now let's simplify this a little bit. X times x gives us x squared. X times 2 gives me 2x. Over here, this would be 2. X plus 2, x minus 2 is x squared minus 4. Now I can work that out just a little bit more. X squared plus 2x plus 2x squared minus 8 is equal to 8. Now combine like terms. So I want to combine the x squared with the 2x squared to get 3x squared plus 2x minus 8 is equal to 8. Now, in our last problem, we were left with a linear equation to solve. So all we had to do was add 9 and divide by 2. In this equation, we're left with a quadratic equation because of our x squared term. So for a quadratic equation, I can either solve it by quadratic formula or factoring. I usually try to solve these by factoring because the numbers are generally pretty small. So I need to make one of the sides equal to 0. So I would need to subtract 8 here to make that equal to 0 and subtract 8 there. Okay, so that's going to give me 3x squared plus 2x minus 16 equals 0. Now from here, you can either do, like I said, factoring or quadratic formula. I'm going to try factoring first. For 3x squared, I will use 3x times 1x. For 16, I'm thinking 8. Oh, maybe 8 and 2 would work. Let's try that. 8 and 2. That'd be 6 and 8. Yes, if I made the 8 positive and the 2 negative. Okay. Now, I'm going to solve this. So for my first parenthesis, I would get x equals negative 8/3. For my second parenthesis, I would get x equals 2. Now, going back to our domain restrictions, we have to determine is either one of these an extraneous solution. So look at the things that x cannot equal. X cannot equal 2 or negative 2. That means this x equals 2 is extraneous. So our only solution, our only real solution here is x is equal to negative 8/3. All right, example 3. We have 13 over 3x minus 3 minus 1 over x minus 1 is equal to x over 9. So let's see. This first denominator, I need to factor out the common factor. So I have a 3x minus 1. All right, now I'm going to look at all my denominators. I have a 3 parenthesis x minus 1, an x minus 1, and a 9. Let's get the domain restrictions first. What can x not equal? Okay, think about that. All right, hopefully you said the only thing x cannot equal is 1. All right, now for our LCD, we're going to need the 9 and the x minus 1. All right, so 9 parenthesis x minus 1 times 13 over 3 parenthesis x minus 1 minus 9 parenthesis x minus 1 times 1 over x minus 1 equals 9 parenthesis x minus 1 times x over 9. All right, again, I know that step takes time, but trust me, it's worth it. All right, now cancel what you can. So first of all, the 3 goes into 9 3 times. The x minus 1 cancels with the x minus 1. In the second term, the x minus 1 cancels with the x minus 1. On the right side of the equals, the 9 cancels with the 9. All right, now we have 3 times 13, which would give us 39 minus, did I make a mistake there? No. Here, minus 9 equals, and on the other side, x parenthesis x minus 1. It felt to me like I was making a mistake because there's no variables on the left side. But sometimes weird things happen with rational equations. Don't let it throw you. I just check your work and go on. So I just checked myself, and I'm pretty sure I've got this problem right. We'll see at the end. So we have 39 minus 9, which gives us 30. And on the other side, we have x times x, which is x squared. X times negative 1 is negative x. So what I have is a quadratic equation. To solve this, I need one of the sides to equal 0. So I'll make that side equal 0 by subtracting 30. All right, and when I do that, that gives me 0 equals x squared minus x minus 30. Oh, and that's going to nicely factor because I can use x and x for x squared, 5 and 6 for 30. I need to make the 6 negative and the 5 positive. So x equals negative 5, x equals 6. Now let's check to see if either of those are extraneous. Go back up to the top. The only thing that x could not equal was 1, so these are fine. Sometimes you'll see the solution written in a solution set like this. I'll use braces to indicate that these are both x values. If I would have done this, I would have done this, negative 5, 6 in parentheses. That would have meant this is an x and this is a y. So don't use parentheses. Use your braces to indicate they're both x values. So x equals negative 5, x equals positive 6. All right, problem B. X over x minus 2 plus 1 over 5 is equal to 2 over x minus 2. Pause the video and try this problem on your own. All right, welcome back. Let's start with domain restrictions. Hopefully you put that x cannot equal positive 2. And hopefully you recognized that your LCD was 5 parenthesis x minus 2. So 5 parenthesis x minus 2 times x over x minus 2 plus 5 parenthesis x minus 2 times 1 over 5 equals 5 parenthesis x minus 2 times 2 over x minus 2. Now, if I cancel what I can, this would x minus 2 cancels with x minus 2, 5 cancels with 5. Over here, x minus 2 cancels with x minus 2. All right, let's write down what that leaves me. On the first term, we have left a 5 times x, which is 5x. On our second term, we're left with x minus 2. On the other side, we're left with 5 times 2, which is 10. So this would be 6x minus 2 equals 10. So add 2, 6x equals 12, and divide. Now check your domain restrictions. So I want to go back to the very beginning, and it said x cannot equal 2. Now in this problem, that's the only solution I got, which means this is an extraneous solution. So our final answer here would be no solution. Or I could use the symbol. Okay. All right, problem C. Pause the video and try this problem on your own. All right, welcome back. Hopefully the first thing you did was broke down this first denominator to x plus 6, x plus 2, and you got the domain restrictions that x cannot equal negative 6 or negative 2. Excuse me, I messed that up. Oh goodness. X, this was supposed to be x minus 2. This is supposed to be positive 2. So x cannot equal negative 6 or positive 2. Hopefully you figured out that the LCD was x plus 6, x minus 2. So when I work all that out, x plus 6, x minus 2 times 4 over x plus 6, x minus 2 plus x plus 6, x minus 2 times x minus 1 over x plus 6 equals x plus 6, x minus 2 times 1 over x minus 2. All right, canceling what I can. All of that would cancel with all of that. X plus 6 cancels with x plus 6. Here, x minus 2 cancels with x minus 2. So that leaves me 4 plus x minus 2, x minus 1 equals, on the other side, x plus 6. So this would be 4 plus x squared minus 3x plus 2 equals x plus 6. Combining like terms on the left, x squared minus 3x plus 6 equals x plus 6. Now I need to make one of the sides equal to 0, so I'll subtract x here and subtract 6 here and here. So that gives me x squared minus 4x equals 0. Factor out the common factor of x, which that would leave me x parenthesis x minus 4 equals 0. So my solutions would be x equals 0, x equals 4. Check your domain restrictions. So we're good. Both of these are solutions, or you can write it in this form, 0, 4. And that concludes today's lesson, solving rational equations.